Hey everyone, I'm so sorry that I'm not there today. Corbin's been battling some cough and fever and he's just not quite there yet. So hopefully you'll see me on Wednesday. But we are on page 5 of this packet. And I wanted to show you a couple of examples and then have you rally coach with your partners. Same partner that we worked with in those first 2 pages. But last time we met, we talked about how to find the unit rate from a graph. And remember, we went to, over to 1 on the x-axis and then went up, or we did the y divided by x to find that unit rate. That's going to be true today of when we're finding the unit rate from the table. Now we have to be careful because we also need to label our answer with units. You guys did a really nice job of doing that. So when we're talking about number 25, we're doing distance and time. In tables, our first column is our y, or our x, and our second column is our y. We can find the unit rate by doing our y divided by x, where y is talking about minutes, and distance is talking about miles. So we're trying to find out how many minutes it takes us to drive 1 mile. We're going to go ahead and do 36 divided by 3, which is 12 minutes per mile. And the nice thing there is if you did 72 divided by 6 or 108 divided by 9, you'd still get 12 minutes per mile. So that part does not matter. Now down here, number 29, it gets a little bit more complicated, and it's a good thing that we get to use our calculator. When we have horizontal tables just like this, where the information is going from left to right rather than from top to bottom, you have to be careful about what you label as your X and as your Y. Unfortunately, on this table, it's actually wrong. Normally, your X value or your independent variable is going to be on the top and your dependent variable is going to be on the bottom, or the Y. Well, here's the deal. The cost of the oranges depends on how many pounds you purchase. They have this table backwards. Now down here on number 32, it's actually correct that the X and Y being the top row, X is the top row and Y is the bottom row, is correct, but 29 is not. I wanted to make sure to clarify that. So that means that my cost depends on the pounds that I purchase. So Y would be the cost of oranges because it's dependent there. Normally we'd take the bottom row and divide it by the top row, but since this one's wrong, it's already kind of set up for us. We want to know how much it costs for 1 pound. You're going to take your 27 cents and you're going to divide it by 1/4. Now you can think about 1/4 instead of typing it in or doing the math with a fraction. You can go ahead and convert that 1/4 to 0.25 or 25 hundredths. And then you can just type in your calculator 27 hundredths divided by 25 hundredths. Or you can get in the habit, again, of dividing numerator and denominator by our denominator. And we get that the unit cost for cost of oranges would be $1.08 for 1 pound of oranges. And that's not 1/116, that's a B. Okay, I want you to go ahead and rally coach through this page with your partner for about, I would say, 10 minutes or whatever Ms. Letts thinks is reasonable. And then we need to go on and talk about some of those word problems. Okay, on this page, this is page 6, I think. Calculate the unit rate for each table, then use the unit rate to answer the questions below. We're going to round all answers to the nearest hundredth. The table below shows the weight loss goals that Mr. Smith set for the new year. Time is going to be our X value and weight loss is going to be our Y. The weight loss depends on the amount of time that it takes. How many pounds does Mr. Smith want to lose pre-month? Not pre-month, per month. Okay, so how much does he want to lose per month? We're going to take our Y divided by X. I'm going to show my work over here and do 12 and a half. I'm going to go ahead and write that as a decimal. Pounds in 4 months. Divide the top and bottom, numerator and denominator, by 4, and we get 3 1/8 pounds per month. So the answer up here would be 3 125 or 1/8 pounds per month. That's a pretty healthy weight loss goal. If Mr. Smith needs to lose 50 pounds, how many months will it take him? And this is where we're going to want to set up our WCOO chart. I'm going to erase all this workspace. You want to keep it on your paper. I just don't have the luxury of having a whole bunch of space to work with. Here's my chart, WCOO. So our word ratio that we're dealing with here is pounds and months. Those are our labels. If our known ratio would happen to be, it could be any of these 3 ratios that are listed here, or it could be our unit ratio. We're going to go ahead and let's use for giggles, since yesterday we did, our unit rate. Let's just look and see what's going to happen when we use something different. For whole numbers, I'm going to use the 25 pounds in 8 months. And we want to know how long it's going to take him to lose the 50 pounds. So 50 pounds is going to be here, and we don't know the month, so that's going to be an M. Set up your proportion. You can go ahead and do your butterfly, or for those of you that like to rock your mental math, you know that 25 times 2 is 50, and 8 times 2 is 16, so the answer would be 16 months. It'll take him 16 months to lose that. Part C, if Mr. Smith loses weight at this rate for 2 years, how many pounds will he lose? Okay, so it's talking about 2 years. We're going to have to do a little bit of math magic here. Still going to use that same ratio of 25 pounds in 8 months, but we have to be careful when we're filling in our unknown side because it's talking about 2 years. And our time frame is in months. So instead of writing a 2, I'm going to write a 24. And then I've got my pounds that I need to figure out. Again, you can do your Billy Bob Joe the Butterfly where you set up and do your cross products. Or you can notice that 8 times 3 is 24. So 25 times 3 will give me the amount of pounds, which is 75 pounds that he will lose. If there's any time remaining, go ahead and take a minute or two to work with your partner on finding that unit rate and setting up your WCOO chart. But before you do that, we need to talk about the last page. Then you can go back and look at this problem. Let's look at number 39 for a second. On problem number 35, we have prices of different fruit that we are kind of comparing. And we've got to answer the questions based on that. We're going to order the fruits from least to most expensive. And here, they're kind of asking you to look at the steepness of the line. If you look at blueberries, the cost goes up really fast. It's like shooting like a rocket in a short amount of time. So blueberries would actually be our most expensive. Peaches are kind of middle of the road, and oranges, the cost doesn't go up so much as the time continues on. To order them from least to most expensive would be oranges, peaches, and I apologize for my poor handwriting, and blueberries. If the unit rate of peaches is $1.20, which of the following could be true of the unit price of blueberries? Peaches were kind of middle of the road, so blueberries we would expect to be more expensive. And the only option there that's more expensive than $1.20 would be the $2.50. Part C is saying if the unit price of peaches is $1.20, which of the following could be a unit price for oranges? We're looking for, oranges are less expensive, so we're looking for a unit price that is less expensive than $1.20, which leaves A as our only option. All right, for your homework, you are needing to finish every single problem in this packet between the last class period, so Friday. You were supposed to finish pages 1 through 4. If you were good and did your homework just like you were supposed to over the weekend. If you didn't, you have some catch-up time because we're not going to grade this until tomorrow. So everything in this packet is due tomorrow, as in Wednesday at school. Please do a good job showing your work. Ask good questions if you don't understand. And I will see you hopefully tomorrow. Have a great day.